Good afternoon, everybody. Thanks for joining this session. And it is my pleasure to present to you today on this topic of continuous testing with intelligent test automation that is powered by artificial intelligence. And as Vidhi said, I've been in this business for over 20 years now, and starting my career with Mercury and then later with HP and now with Micro Focus. And I've seen the evolution of the test automation industry over the last 2 decades. And in this session, I'm going to talk about what's going to be the future of automation, how we see it as one of the pioneers in the automation technologies, and how we are addressing the current needs. I'm going to present for about 20 to 25 minutes, and then my colleague Chandrashekhar is going to take over, and he's going to actually give us a demonstration of how AI-powered test automation works. So with that, let me just get into this presentation and start off with putting some context in place as to how automation has evolved and what's the complexity that we are dealing with today. And we know that today the business is putting extreme demands on IT teams, on application and testing teams to deliver faster. But if we go back in time, obviously in the 80s and early 90s, it was all about manual testing. And then late 90s is when we started looking at automation. But it was really with the internet and more and more applications coming into the fray that we started dealing with a lot of applications and test cases. And by now, we have thousands of test cases to deal with, and that's when more robust automation uh, took off. And actually, I started right before that .com era, and I started working with a tool called Windrunner, which was actually the precursor to QTP, which later became functional testing and UFT now. So once we had the mobile revolution happening towards the end of the 2000s, we started looking at digital first initiatives. A lot of digital transformation initiatives are still driving the industry. And today we are looking at tens of thousands of tests because now you have to run the same set of test cases across different platforms, devices, form factors, browsers, etc. So it's becoming more and more complex, and it's all about scale from here on. So how do we deal with this challenge as we look at even more scale, more complexity going forward? So we realize that this future is going to be powered by autonomous testing, machine learning, and AI capabilities. And the good thing is that these technologies around artificial intelligence, computer vision, some things I'm going to talk about, have really matured in the last few years that make it possible to do actual vision-based object recognition rather than the traditional object recognition based on the object properties. So the goal is to be able to work smarter and leverage the power of technology to our benefit. Now, to work smarter really means working across all the areas of automation, be it the test design, the test automation creation, and of course, test maintenance. So currently we are focusing on test automation and test maintenance, and we are also moving towards a better test design capability, say based on model-based testing in the near future. But today I'm going to focus on how we can leverage the power of test automation, which is using AI, and then how that is really impacting the maintenance effort that goes behind all the automation that we do. But before I talk about automation and test maintenance, let me just put a quick word out there about AI technologies by itself. And almost every business today is looking at how we can improve efficiencies or bring about innovation using AI technologies. Almost 83% of the businesses say that it's a strategic priority for them. Analysts have been forecasting for a while now, and IDC says that 75% of commercial enterprise apps will use AI. By 2021, we're also talking about emerging technologies that will have AI foundations. But the actual numbers are actually much lower today in the workplace. Only 37% are using AI, or digitally mature organizations that have a well-defined AI strategy is only less than 50%. Right? So we want to exploit these technologies of artificial intelligence, machine learning, deep learning. And I just want to speak a few words about how this technology is really working for people who may not be familiar with it. So machine learning is really based on neural networks. So here we are looking at, let's say, a couple of images, and we are asking the computer to process the image and make a decision whether it is a home button or whether it is not a home button, right? And with deep learning, we're going to further add to this algorithm, and it's going to have some self-learning capabilities. So the way software in artificial intelligence is working is really you have to first train the algorithm to perform simple tasks. Now, for a human brain, these are very simple. As we grew up, our brains have learned to process information, process data, and make a decision and realize that, okay, here's a home button, or here's a search button, or here's a shopping cart button. And regardless of the actual form factor or the nature of the image, we can recognize all of these as cart buttons, or we can recognize all of these as profile buttons. The whole idea is that can we build a computer-based model that can process any of these images and say, okay, it's a card, and process any of these buttons or profile and say that it's a profile button. So that's what training does to the model. So you have to feed training data that will eventually start processing these images to know. And behind the scenes, there is pattern matching, or pattern matching algorithms that are playing their part in this process. So we kind of do pixels, and then we do segmentation of the image into various subsections, and it processes it at different layers to actually arrive at the decision. So again, I'm not going to go into details of this technology, but this is what we are embedding into UFT to make it AI enabled, so that when we feed an application to UFT, it's able to use that model and infer what object it is. And based on that, we're going to act on that object to drive the automation. So that's as simple as it sounds, but behind the scenes, there is a lot of complexity. Some of these technologies are quite mature, as I said. Examples that you might be already seeing are, computer scanning CT scans and MRI scans, or autonomous cars driving on the road and understanding here's a stop sign, here's a traffic light, here's a car in front of me or a pedestrian in front of me, and accordingly taking the decision. Similarly, we have robots on the shop floor of factories today, or even customer support robots that are responding to calls, etc. This is all the different applications of AI that we are quite familiar with now, and the same technology we are going to now apply to automation in testing. So before I now talk about how this is applied to automation, it's once again important to understand. I showed you that graph earlier, how we got there, the context and the scale and complexity that we are dealing with today. But let me just pinpoint three big reasons why we have challenges in scaling automation. The first, of course, is frequent releases, which means that there is a lot of maintenance effort every time we release a new application version. We realize that a lot of our test scripts are breaking, and that's making it difficult for automation teams to keep up with the changes in the application, which means too much maintenance effort, very little ROI, and that's when people start giving up. Then, of course, there is the scale at which we need to deliver, which is demanding a lot of time and effort. It's because you have to test on an Android and iOS, on a mobile web browser, on even a desktop browser, the same test case. And that means you have to build four different scripts. I'll stress on that point very quickly in the next slide. And then let's not forget that the automation skill set is also not very abundantly available. I think people are looking for ways to simplify it. And what we are doing there is we are actually going to talk about natural language processing and how we can actually have an automation script that looks pretty much in plain English. So just to stress on this example and challenges that I just talked about, here's a shopping application, an online shopping application. I can buy laptops, tablets, speakers, etc. And I have an Android version, an iOS version, a mobile web version, and also a desktop version, which means that traditional automation technology requires me to build four scripts to test a simple business process of buying an item on an e-commerce application. So that's my time to market challenge. But also, every time I release a new version of this application, it is likely that I'm going to keep breaking my test automation scripts because of all the code changes that might be going on, the the new build that we are compiling might actually offset the current identifiers and make the scripts to fail, which is where we have to spend a lot of time maintaining the scripts. So I'll stress this by a simple example here. I have my traditional automation using UFT, and I'm going to automate a script to just log into this e-commerce application. All right, so I'm just playing a small video here. I run the script and it's going to run on this Android device. Click on the hamburger menu. I will click on the profile button, the login. And remember, this is all traditional automation, which means there is an object repository that recognizes these objects. And based on that, we recognize the object and click on it. And then we have our test results, and we can go ahead with this. Now, what we're doing is making a small change to this application. So you just saw how that script worked. Now that hamburger menu, instead of on the left side, we're going to move it to the right, and the shopping cart to the left. Now, this is a requirement that came from the business, so the developer went ahead and made that small change. But what it did to our script is that because our script identified this object by its location, maybe some index on the application in the code, the script is actually going to break. So let me just play it out. You can now see the hamburger menu is on the right side. I'm replaying the same script. And this is again just to illustrate the challenge that I talked about around test maintenance. So now actually I can't find the login button. Instead, I've gone to the shopping cart, and that's led to the script failing, which is because the object could not be found. I could not find my login or a profile button to log in, which caused the script to fail. So object identification based on physical properties, changes in the application implemented leads the automation to break. So as a human being, would that manual test have failed? Probably not, because as a human being, I would have been given a test case. As a manual tester, I would have said, okay, I need to first log in. I don't care where the button is. I just click on the profile button and I log in and I start shopping for my product. But the computer, because it was programmed, the automation script, because it was programmed with some object properties, it failed. So we are now saying that let's build capabilities within the tool so that it sees like a human being, regardless of an Android app, regardless of an iOS app, regardless of a desktop browser or a mobile browser. As long as I have visual identification of the object, be it to input something in the search field or clicking the search button, going to the profile button and logging in, adding to cart, it looks pretty much same across platforms, across devices, across browsers. As a human being, as a manual tester, when I can do that, can't I do that with automation? So, which really takes me to the three technologies that we are baking into UFT that represent AI capabilities. So we have firstly the eye, which is the computer vision that identifies object just the same way a human does. And as I said, we've been training our AI engine for almost 2 years now, right? And you would have realized that any AI algorithm that is trained with more data set is now getting more and more accurate. Think about your Alexas and Siris of the world. There are now millions of data points that they're so accurate. They recognize every word that we speak. Same way we have been training the eye of UFT, the computer vision, with thousands of images already, and it's very well, being trained by now. And the brain behind it is really the neural network, which I explained in one of the earlier slides, which lets the tool interpret that, hey, this looks like a shopping cart, this looks like a profile button, this looks like a text box where I need to enter username. And that's because it processes that image. It is not a bitmap. In fact, some of the users of UFT might know that we had the bitmap based image, insight image based recognition almost 8 to 10 years back in UFT already, but it was very pixel based, bitmap based. That's not AI, right? You just do a bitmap based pixel to pixel comparison and click. But AI is actually going to process the image and use the neural network to understand that this matches the pattern of a shopping cart. This matches the pattern of a search button. And hence the accuracy really increases a lot. You're not dependent on object moving around on the screen. You're not depending on the shape changing us, here and there. And obviously that makes it independent of the properties of the object as it might be defined in the OS, in the DOM, etc. So both UFT1 and UFT developer now are using this technology. And last but not the least, natural language processing, which means the script that we are going to generate with AI-based capability should then be readable enough for a manual tester or a non-technical business user tester to interpret what the test is doing and make the job easier so that everybody who's responsible for automation or testing rather can participate in automation. So with that, I'd like to hand it over to Chandrashekhar, who's going to take us through a demo. We're going to see how we design a test. And in this case, we have a couple of options. You can actually record the test in the traditional way. You can also shift automation extreme left. In fact, one of the first things that he's going to show you in designing your automation is if you have UI mockups. Now, because we are going by visual identification, you can use your UI mockups to build automation, right? And of course, we'll show you how to record a script which recognizes objects by AI-based vision. We also will show you how a feedback tool can send us information about, say, an object which is not currently being identified by AI in UFT. And using the feedback tool, you send us a ticket and we train our existing AI model to build AI recognition capabilities on that. Then we will execute the same test case of shopping online on this e-commerce application. We will run it on a Chrome browser with French language, then we'll run it on an iOS device, and then we will run it on a Chrome browser with English language, or Firefox with English language. And finally, the demo is going to show us how very extensive reporting can be created out of UFT so that the developers, the designers, the business, everybody can understand why a certain test case is failing. You can do drill down, root cause analysis. And that's again something that many of the UFT users would be familiar about the reporting framework in UFT. So with that, I'm going to stop sharing my screen and request my colleague Chandrashekhar to come online and walk us through a demonstration of AI-based capability in UFT.
Yeah, hi Manish. Thanks for handing over it to me. So, are you able to see my screen, Manish?
Yes, we can.
Okay, thank you so much. So, as Manish has rightly mentioned about the AI capability, so I just wanted to uh, uh, so whenever you work on any of the automation projects, and say for example we have an automation pipeline in place, and say because of this simple change which we have it, because the simple change which you have it on that login button which we have it on the page, so we see that this our script has got failed. And if we have an automation pipeline or DevOps in place, we see that many times we had such kind of a maintenance, and we'll have to handle it on the fly, or we'll have to handle it in our script. And we see that there is a huge amount of maintenance which may come into the picture because of the changes which are happening on a happening in your application. Say so nowadays, so we talked about the earlier life cycle of an automation. How does the automation has got evolved? So see, starting from 2000 till to 2020, you might have seen that there is a evolution of so many automation tools which we have it in place. But the way the objects gets identified in these tools mostly depends on an object physical properties, right? And that's where you might have seen that many of the scripts are getting failed because of the changes which are happening in an application due to the object physical properties, right? And that's where the AI capabilities are coming. AI capabilities will definitely help us out to have a robust or resilient script which will support the entire portfolio which we have. It say if I have a browser-based application, if I have Android-based application, or iOS, or even say the multiple or tablet-based applications. So you can execute the same script on a multiple browsers as well as multiple devices as well, and that's what the AI brings benefit when you do an automation and you will definitely see that you will have very limited maintenance when you use AI. So there will not be a maintenance, there will not be much maintenance as we have it now. So that's where the AI is bringing up out that as a major benefit, right? So let me just, so here, as Manish has already briefed about the demo, so we are going to have a demo. I'll just brief you how we can design the automation script using UFT, how we can use a feedback mechanism where, so because of this feedback, what happens basically, we will get the, so there might be some customized objects you have it in your application, right? And that will, your feedback in identifying these particular objects will definitely help us out to increase the data repository of the objects which you have it in our repository. I'll execute one script where you will see that the script is going to be get executed onto the multiple devices as well as multiple browsers. And at the end, we'll see the reporting part where how the reporting looks, as you might have already familiar with UFT. However, you will see that if the migration has to be there, so we'll have to migrate the script from the traditional UFT to the AI capabilities. So how we can do that? So that will also I'm going to brief you on that as well. So let's move on to the design. So I'll just run through one of the flow which we have created on the shopping application which we have just shown. So it's a UFT itself, so the UFT which we have, which we are using it since long time. Okay, so so the way the object identification used to take place earlier, it's either recording or it's either writing a descriptive programming or some or other way we used to identify the objects. Now, what change which we have come up in the UFT using AI is basically, the object identification methodologies has got changed a bit. So here you can see this particular icon, the application which we have. That's not the actual application. That's the image or you can say the design documents we have it, or the wireframes which we have it. So before doing an actual, say for example, you don't have an application ready. So before having the application ready, you can still go ahead and start doing an automation based on the UI mockups which we have it in place, right? And that's where you can see this is the UI mockup which we have it, the UI mockup of the online shopping application which we have the login screen, and again the different set of devices which we can see it on a page, right? And you can see the way we identify the objects. So we basically identify the object in AI based on the visual element. So you can see all these are the visual elements which has got identified using the AI capability which we have it in place. You can also see there are a couple of text boxes, or you can see the text objects which you have it on a page. So here, rather than visual element, even I can select a text option, and then all these text options or text objects will get identified based on the AI capability which we have it in place, right? And that's where the major benefit which we are getting it out of the AI, because you can start doing an automation at the start of the project itself or before the start of the project itself, right? And that's the major benefit which we are getting it. Now let me continue executing the script. Now you can see the way the objects gets. So here, what is happening? So all these objects, you can see it on the login page. Okay, so you have a username, you have a password, right? And then you have at the down, you can see drag and drop the identified objects, elements which we have it on a page. So you just have to drag and drop these particular objects which you have it on a screen, and you can see the statement which is being written for that particular object. So earlier you might have seen that if I allow to go to the particular page or particular object, so complete statement will be get written, and then after that you'll have to perform an action. But here you can see it is just we are just typing something in a username, right? So that's where the benefit which you're getting it, and there is nothing else you have it over here. So it's basically those who don't have a understanding of an automation, or those, take an example of the business analyst or the other guys, those who don't have much understanding of automation, they can even able to automate the scripts based on the wireframes or based on the application which is there, right? So let me just execute the script, and you can see it over here. How we are dragging and dropping the objects, and then how does the script is getting generated. Now this is the one way of identifying the object. There is a different way of identifying the object is since the evolution of this UFT, we were using the recording and playback, right? So recording feature is still exists, and we can record the AI objects. We can add the checkpoints. We can do whatever the operation which we wanted to have it on that particular objects. So here, what it is doing, it is searching for that particular product, and then I'm adding it to the cart. And if suppose you wanted to have a checkpoint at that object level, you can add the checkpoint at object level. You can add the checkpoint at text level as well. So that's the other benefit which you can see it over here. And the last one, which you can see it over here, that is where your application is ready, and then I wanted to identify the object. So here, what is happening? So let me take it a bit back. So here you can say the application is available, application is ready, and then you can just change the whether you wanted to identify object, visual element, or you wanted to identify text element. According to that, you can change it, and then you can identify the object as per your convenience. So that's where you don't have to deal. It's basically visual based as well as the text based object recognition which we have it in place. Okay. So you can see the benefits, the key benefits based on this, the key benefits which we're getting it out of this are basically how you can accelerate the test design. As I said, like we can use the wireframes or the mock-up designs. We can record the script. Even we can use the AI identification capability of UFT AI. So that's where we can definitely accelerate the test design, because I many times I see that the customer say that no, we have very limited automation coverage, or whatever the automation coverage which we have, we were not able to leverage that automation scripts because of the maintenance which we have it at an object level, or because of the changes which we have it because of the agile methodology which we are using it. And that's where, if we have this AI capability in place, and that is going to definitely help us out to design the test cases in a faster way. And you have seen that how simple the script creation is. And if there is a change happens in any of the objects, so you don't have to make a change in the script at an script level, because the object is already there, and you don't have to make any change for any of the whether it is a browser change or browser based change, or whether it is device based change, or whatever it is, or so you don't have to make a change in a script. And lastly, as I said, even the business analyst can write the automation scripts because of this AI capability. Right? Let me move on to the feedback. So as I said, like there could be a couple of objects where we were not able to identify, because these objects might be customized objects, right? So that's where we need a help from our customers to increase the data repository. So you can see this is the particular object secure pay, which you could not able to identify based on the methodology. So here we expect the users, or we expect the customers to help us out to enhance the way of learning the objects. So once we receive the feedback from the customers, we could enhance our learning objects or learning repository according to that. That's the feedback we are expecting from the customers while working on this particular AI capability. The next one is the execution. Now, as I said, like so you may have in earlier traditional approach, so you may have a separate script for, say, Android, separate script for iOS, separate scripts for different browsers. And that's where you might have seen there could be huge maintenance if there is a change in any of the functionality in any of the application, whether it is a native app, whether it is a hybrid app, or whether it is a different type of app, right? So there is a huge amount of maintenance which we can see it when we are using the traditional method of identifying the objects, right? So what I'm going to do it here, I'm just going to execute the script, which you can see that's a single script which I'm executing on a multiple set of data which I have it. So here you can see again it's the along with UFT AI, we are using the all of the features of UFT as well, right? So data driven, we can use the data driven testing and then pass on the data which is required for that particular script. So here we have browser-based script. We have a browser. We are executing the same script on a browser as well as a different set of devices, and a Firefox as well as Chrome browser. as well as this particular script is getting executed in a different set of languages. So be it a French, be it English, or be it any other language, you can use the same script to execute it on a multiple set of browsers as well as devices, along with the multiple language, localized language as well. So let me just execute that. I'm just so this will first of all execute the script on a French language application, which is in a Chrome browser. Right, so you can see all these objects. So despite of change in a language, you can easily identify the objects and execute the script for that particular localized language. Right, so you be it a French, be it any other, be it a Danish, or be it any other language, you can do the execution on that kind of a language. Now the same script is getting executed on a Android-based device, right? So the same scripts, even whenever we are doing your app-based testing, we are doing a testing onto the multiple set of devices, right? So in Android, you may have say 10 different devices on which you'll have to do the testing. So the same script can be get executed on a 10 different set of devices as well, even in iOS as well. Now, so at the end, so as I briefed you on the multiple set of platforms and languages, so let's move on to the next, the way the report looks. So when you execute this particular script, so you can see the set of statements which gets stored over there in UFT report as well. So you can see it over here. So different set of statements which has got logged over there in UFT, right? So yeah, util profile dot click. So if suppose I wanted to identify a specific object, you can easily go and identify that specific object based on the name which you has given. So it's very easy to identify the objects. And if suppose tomorrow, now it is a profile, right? So if suppose tomorrow it has got changed to something else, from profile to profile 1, 2, or 3, so I can directly go to that particular repository, particular script, and make the change according to that, right? And that's where it is very much easy to make the changes in your automation scripts. Now, say for example, earlier you may have the way the object identification is to take place in a traditional way. So right, so here what generally we can have it. So say for example, let me just show you one of the oops, sorry. Okay, so say for example, if you wanted to make a changes into your current script, so there is a capability which we have it in UFT, where you can go to the options, GUI testing, and you can go to this AI option, and there you have an AI transformation assistant that will help you out to understand how you can make the changes in your scripts based on the AI capability. So it will give you the suggestions at an object level, and you can make the changes in a script. So that's the migration, that's the help we can have it at the time of doing a migration of an or automation script from the traditional to the AI. So let me show you how it displays.
Chandrashekhar, we just have a few minutes left. We need time for QA as well. So I would like to tell you to cut it short, please.
Sure. So finally, the last slide which I could. So because of this AI capabilities, we can definitely see that there is a very less amount of maintenance we'll have to do it in our automation script. So we can say that we can cut down on the maintenance up to 70% reduction we have in maintenance. There will be increase in automation coverage as well because of this AI capability. We can execute the same script on multiple devices as well as multiple browsers. So that's where it's a 3x increase in the automation, and even we can extend this capability to the developers, to the business analysts, and definitely they can be a part of doing an automation scripting as well. So these are the benefits we can get it out of this AI, UFT AI. That's it. Thank you so much.
Yeah, thanks, Chandrashekhar.
Yeah.
I think you can stop sharing your screen, I think.
Yeah.
So we can take a few questions here.
Thanks, guys. I will, since Ramit is not here, this Vipul Kochar, I would be handling the questions. You would be handling the answers. Okay. So first question is from Vipul Kochar. That's me. Okay, so I can't take that question. All right. Well, actually, there are some classes of questions. So I will first tell you the class of question where you have large number of people asking this question, which is related to pixels. So essentially, control may change, the images may change by a few pixels and so on, or the resolutions may change and so on. So how does the tool handle? That's a set of questions. Please.
Yeah, absolutely. I'll take that question. And this is the big difference between the traditional image-based recognition versus the AI-based, right? So when we talk about an autonomous car today, it's different pixels on different streets, right? When the car is driving. It's because the AI engine processes that image and converts it into something more, you would say, uniform that it can relate to or identify, is how it is actually differentiating between objects and making a decision. So regardless of where it is on the screen, whether the resolution is changing, even the form factor, right? I mean, if you go and search on Google Images for a search button, the magnifier glass, you'll find hundreds of them. But the way AI works is it knows that this is the pattern. A magnifying glass has such a pattern that there's a circle and then there's a rod connected to it, right? Or a shopping cart looks the way I showed you the four different icons of a shopping cart. It has nothing to do with pixelation. It's entirely on the pattern matching and how it identifies.
All right. Thank you so much. So I hope all the people who asked these questions have got their answer. Second question is related to your licensing. UFT and UFT One are the same, and
Yes.
does somebody need to pay you extra?
No. So anybody who has UFT today has UFT One if they are currently on our support contract, and they can upgrade to the latest version, which is 15.02, and they will have all these AI capabilities. They don't have to pay extra.
All right, wonderful. Third question is this related to asked by Raghavendra. Does UFT support BDD approach to automate applications?
UFT developer does. So there is a developer edition. You might have seen it on the screen. So it supports the BDD framework. UFT One does not. I'll be honest about it. UFT One, which is what I think most of the people use today, which was the evolution from QTP, it does not support BDD yet. But we announced it 2 months back in our public forum that we are working on a model-based testing approach. So there are already plans to launch those capabilities within this financial year.
All right, wonderful. Thank you. Next question is there CAPTCHA handling?
Well, the function of the CAPTCHA is to not let automation tools work. So I would resist commenting on that. I don't think we want to disrupt that entire industry.
Understood. Thank you. Next set of questions relate to self-healing, headless testing, and so on. So both, self-healing as well as headless testing. Do you have any?
So headless testing, as we see it, I mean, what I think most of the industry refers to as API-based testing, that's already part of UFT. It's been part of UFT since it was named UFT. Earlier, we used to have a separate product for service test and a separate product for UI-based testing. When those two merged, that's when we started calling it Unified Functional Testing or UFT. So that's headless testing. Chandrashekhar, you wanted to add something on headless?
Basically the headless testing, as you said, so if you wanted to connect to any of the devices or say the Chrome browser will not get launched and you will be able to execute the test script in the background mode. So that's where, yes, it supports the headless testing as well.
Okay, so if that's the question around that, then yes. And then on the self-healing part, I think the whole idea is that if we remove the dependency on the object repository, as long as the visual identification is retained, then we don't have to worry about healing because the script is independent of the code changes.
So in that sense, you can call the system self-healing, that the changes are identified and taken care of. So in that sense,
yes, the whole idea is to reduce maintenance. I think that's the biggest problem plaguing this industry or the practice of test automation today.
So I want to ask you a question on behalf of the entire community here. That initially people said capture replay is bad, capture replay is bad. Now that you're saying your automation takes care of the changes and so on, you just do capture replay once and everything else then is taken care by AI. Are we going back to where we started from?
When you say capture, you said capture.
Capture replay.
Okay.
Or record and playback, whatever. So are we going back to the beginnings where we started with capture and replay or record and playback, and then we started building scripts on top of that and so on, and now you are saying just do it visually once and then we take care of it. So have we gone back to record and playback?
No, I think that's where there is a lot of debate in the industry going on, where I think a lot of people are criticizing the whole script-based approach. I think we are still very much in the school of thought that believes that automation has to be engineered, right? So you need to create your framework according to the needs of your application. You need to be able to, if you have to handle complex flows, I mean, the best way to do it is to write a few lines of code and handle those conditions. I don't think we are we are propagating a record and replay. I think we still retain the DNA of automation as an engineering discipline, and you continue to do that with a tool like UFT that allows you to do that. It's just that the recognition of the object, we are making it independent of the object property. And that's why I also said that with UFT developer, which is not even a recording tool, UFT developer is just like Selenium. It works within the developer IDE, right? It's a bunch of libraries. Even that we are talking about identifying objects using AI, so that the developer also can not have to bother about the XPaths and all those object identifiers.
Understood.
No, I don't think we are talking about record and replay here. It's a very different ballgame.
Thanks. That also takes care of a question on whether there is scripting available or not. So thank you so much. There is a question on non-deterministic outputs. So if there is a non-deterministic output from an AI system where the output of same image, for example, might change, or some percentage might change, or the relative confidence might change. So these numbers might change. So how do you handle those?
So we have already set some level of confidence and percentages within the tool, right? So it's supposed to handle to that extent that we have already programmed it in the tool. Beyond that, the script is going to throw a failure. So either it has not been able to identify it, or it's the wrong image, which means you didn't get the expected outcome, and it's a test failure. So maybe, yeah.
Understood. Thank you so much.